Median and altitude are two terms you need to know and how they apply to triangles. A median of a triangle is a segment that goes from a vertex of a triangle, goes to the opposite side, and when it reaches the opposite side it hits the midpoint and therefore makes two congruent segments. So median is used for middle in a lot of different contexts, and it means it hits the middle here also. So when you see the word median, what you want to remember is, okay, this is going to make congruent segments. Median in a proof is going to tell you directly that these two sides are the same. Altitude is another word you've probably heard before in this context of triangles. That's a segment that goes from a vertex to the opposite side. In this case, instead of hitting the middle, the median would go over here to the midpoint. The vertex comes, or the altitude makes right angles. So when you see the word altitude in the context of doing proofs, you want to think, okay, altitudes make right angles. Let me do a short example where you use both of these terms in a proof. It's a short one. Let's say we're given DB bisects angle ADB. Oops, this should be angle ADC. My apologies. DB bisects angle ADC, and DB is an altitude. We want to prove DB is also a median. Let's mark our givens. DB bisects angle ADC. Angle ADC goes like that. And so we are bisecting it. So it's divided into equal parts. So I'll tick mark that. DB is an altitude. So we remember altitude means we're going to get right angles. That's what altitude tells us. So DB comes down here to the opposite side, and we know it makes right angles. That's all we know directly from altitude is right angles. We can't assume anything else. What we want to prove is, given both of these pieces of information, that we can prove that DB is a median. Now let's remember, to prove a statement like something is a median or a midpoint, you prove what it would tell you. You prove what it means. So median means it's going to come across, it's going to make congruent segments. So if I come back over here, I want to prove, in order to prove that DB is a median, I need to prove that DB comes over here and that it makes these segments congruent. So that's going to be my goal. My goal is to get, I need to show AB is congruent to BC. And I'm going to use a triangle congruence proof, as we've been doing repeatedly in this unit. I notice that I have these tick mark patterns here, and with DB is a shared side between these two triangles. So I have the ASA tick mark pattern between these two triangles. That will show the triangles are congruent. So I'm going to label these angles 1 and 2 to make their naming easier. So I'm going to have angle 1 congruent to angle 2 in my ASA pattern. I know that's true because of the bisect statement in my givens. I have the S in my ASA. That's the segment that's a side of both triangles, DB congruent to DB. Can't seem to write DB today. This is because it's the same segment. And then I have this angle down here, angle ABD, one of the right angles, is congruent to the other right angle on the other side, angle CBD. I can't write given because this is not a quote from the givens. So I said, what told me in this in my list of givens that these were right angles and they were congruent? Well, it was this word altitude. So I'll just say altitude. You could say right angles or anything that gives me a hint that you know where this came from, that these two angles are congruent. So I've completed my ASA information. That tells me that the triangle on the left, triangle ABD, is congruent to triangle CBD. I've used the ASA pattern. And that tells me that AB and BC are the same because they are corresponding sides. And finally, what am I trying to prove? What I'm trying to prove is that dB is a median. And this is the definition of what it means dB to be a median. dB comes down here and it makes these segments the same. So then I can say, therefore, because AB and BC are the same, I may conclude dB is in fact a median. Because that's the definition of the word median.